Good morning. It's June 23rd, and this is your daily brief in science. Here's everything you need to know. Eli Lilly and Company has recently made headlines with the announcement of promising results from 3 Phase 3 clinical trials. Quint1, Quint3, and Quint4 focused on their once-weekly insulin efsitora alpha for adults with type 2 diabetes. The Quint1 trial specifically showed that efsitora reduced A1C levels by 1.31%, slightly better than the 1.27% reduction seen with insulin glargine over 52 weeks. Additionally, efsitora demonstrated a safety profile that is comparable to daily basal insulin therapies, with some trials indicating significantly fewer hypoglycemic events. The Quint1 trial also introduced an innovative fixed-dose regimen for efsitora, which includes only 4 titration levels, aimed at simplifying the initiation of insulin therapy for patients. This clinical trial program began in 2022 and successfully enrolled over 3,000 participants across multiple countries, showcasing the global interest in this treatment innovation. Results from these trials were presented at the American Diabetes Association's 85th Scientific Sessions on June 22, 2025, and were subsequently published in respected journals such as the New England Journal of Medicine and The Lancet. Lilly plans to submit efsitora for regulatory approval by the end of 2025, with the potential to ease the burden of insulin therapy through fewer injections. However, the approval and market availability will depend on several factors, including cost, convenience, and competition from newer non-insulin medications, like GLP-1 receptor agonists. Despite some concerns regarding mild hypoglycemia, particularly during the initial 12 weeks of treatment, efsitora's longer-acting nature may offer improved glucose control options for those with type 2 diabetes. Overall, efsitora's results and innovative approach could represent a significant advancement in diabetes management, potentially transforming the treatment landscape for millions. The Indian Council of Medical Research, or ICMR, has made groundbreaking advancements in the diagnosis of genetic blood disorders. They have developed affordable point-of-care test kits specifically for conditions like hemophilia A, von Willebrand disease, and sickle cell disease. This is particularly significant as hemophilia A alone affects around 136,000 individuals in India, many of whom remain undiagnosed due to high testing costs. Von Willebrand disease has a prevalence of about 1 in 12,000 in certain areas, while sickle cell disease is notably common among the tribal population, accounting for 57% of cases. ICMR has validated a total of 30 different diagnostic kits for sickle cell disease, which include both simple on-the-spot tests and more complex lab-based tests. These efforts aim to enhance national screening initiatives targeting a population of 7 crore. The newly developed point-of-care test kits are priced at 582 rupees per patient, significantly lower than existing lab-based tests, which cost 2,086 rupees. This reduction in cost could potentially lead to the diagnosis of over 83,000 previously undiagnosed cases. ICMR's analysis shows that these tests for sickle cell disease are cost-effective, with new kits available for under 50 rupees. These point-of-care tests are being integrated into national health programs at primary health centers across various states, aiming to improve early detection and treatment of bleeding disorders. The World Federation for Hemophilia has expressed interest in procuring these tests for use in countries where these diseases are prevalent. ICMR's initiative could save the health system around 42 crore rupees, marking it as a cost-effective solution for early diagnosis and treatment. Dr. Manisha Madkaikar, director of ICMR Center for Research, Management, and Control of Hemoglobinopathies, has emphasized pride in having developed these indigenous tests. An international scientific collaboration has made a significant breakthrough in addressing global water scarcity. Researchers have unveiled a groundbreaking nanomaterial that can efficiently extract potable water from atmospheric water vapor, surpassing existing technologies in performance. This innovative nanomaterial, based on calcium intercalated graphene oxide, can hold more than 3 times its weight in water. This enhanced water adsorption is achieved through stronger hydrogen bonding, making it a promising solution for water extraction. The urgency of this research is underscored by the global water crisis, with 2.2 billion people lacking access to safely managed drinking water. Notably, approximately 13 million gigaliters of water are suspended in Earth's atmosphere, representing a substantial potential source of fresh water that this technology aims to utilize. The collaboration involved research teams from Australia, China, Japan, Singapore, and India, highlighting a unified effort to tackle water scarcity. The study, published in the Proceedings of the National Academy of Sciences, was led by the Australian Research Council Centre of Excellence for Carbon Science and Innovation, with significant contributions from UNSW Associate Professor Rakesh Joshi and Nobel laureate Professor Sir Kostya Novoselov. Advanced computational simulations were conducted on the Australian National Computational Infrastructure supercomputer to understand the molecular interactions that enhance the material's performance. This research emphasizes the importance of interdisciplinary collaboration in addressing major global challenges like clean water access. The material was developed in an aerogel form, which is lightweight and porous, allowing for rapid absorption and easy release of water with minimal energy required for heating. By maximizing its surface area, the aerogel facilitates quicker water adsorption and simpler desorption processes, making it an efficient solution for regions with high humidity but limited access to potable water. While the research shows promise, further development is necessary to scale the technology for practical applications in addressing water scarcity. A significant breakthrough in cancer research has emerged from Dr. Takuma Hayashi and his team, focusing on uterine leiomyosarcoma, or LMS, a form of cancer known for its aggressiveness and resistance to treatment. Their findings, published on June 22, 2025, reveal a crucial link between a deficiency in low molecular mass polypeptide 2, or LMP2, and the development of uterine LMS. This discovery establishes the first reliable animal model for the disease through the use of LMP2 deficient mice, a pivotal step in understanding this cancer. In their studies, the team noted that these LMP2 deficient mice exhibited spontaneous tumor development at rates of 36 to 40% by 12 to 14 months, closely resembling human disease progression. Dr. Hayashi highlighted that LMP2 is essential for maintaining cellular health, and its absence can lead to disruptions in normal cellular functions, potentially resulting in malignant transformation. Further analysis of human tissue samples corroborated these findings, showing normal LMP2 expression in benign uterine fibroids, while malignant LMS tumors displayed significantly reduced or absent LMP2 levels, suggesting its potential as a diagnostic biomarker. The implications of this research extend beyond theoretical knowledge. Practical applications have already been demonstrated. 2 case studies showcased how genomic profiling can lead to effective treatments for patients with recurrent LMS. In one instance, a patient experienced significant tumor regression after receiving immunotherapy with pembrolizumab, while another patient achieved disease stabilization with pazopanib, guided by genomic profiling results. Despite its rarity, uterine LMS has a dismal prognosis, with 5-year survival rates below 50% for localized cases and under 15% for metastatic ones, highlighting the urgent need for innovative treatment strategies. Looking forward, Dr. Hayashi and his team plan to develop diagnostic tests for LMP2 deficiency, design clinical trials for targeted therapies, and collaborate globally to validate their findings. They also aim to advocate for improved access to genomic profiling for LMS patients, potentially transforming the landscape of treatment for this challenging cancer. Dr. Hayashi's credentials, including a PhD from the University of Tokyo and postdoctoral training at MIT, alongside his faculty roles at Harvard Medical School and Massachusetts General Hospital, position him as a leading authority in this vital area of cancer research. A routine kidney transplant took a serious turn for a 61-year-old man when he developed a life-threatening parasitic infection that went undetected before the surgery. At Massachusetts General Hospital, doctors initially suspected an infection but faced diagnostic challenges due to the patient's immunosuppressive medications, which complicated their ability to identify the source of the illness. The medical team conducted a thorough investigation into various potential infections, given the patient's compromised immune system. Dr. Camille Cotton and her team utilized a process of elimination, identifying elevated eosinophil levels and unusual signs, including a rash, which pointed towards a parasitic infection. Further investigation revealed that the donor had lived in the Caribbean, a region known for the prevalence of the parasitic roundworm strongyloids, and tests confirmed the presence of antibodies against the parasite in the donor's blood. Subsequent testing confirmed the presence of worm larvae in the patient's lungs and stool, leading to treatment with ivermectin. Despite this intervention, the patient's condition worsened over 10 days, resulting in acute respiratory failure and shock, which required mechanical ventilation and transfer to the ICU. 2 months post-surgery, the patient was hospitalized again with severe symptoms such as vomiting, fatigue, excessive thirst, and fluid accumulation in the lungs. In an unexpected development, the recipient of the donor's other kidney also fell critically ill with the same parasite. However, both patients ultimately survived. In response to this incident, the United Network for Organ Sharing has updated its screening guidelines to include universal strongyloids testing for organ donors from endemic regions. The patient's history included contact with domestic cats and dogs, which raised suspicion for a widespread parasitic infection, although common bacterial infections were ruled out. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.